All right, so this is quadratics number 4. What is a quadratic when you hear that? Quadratics number 4. What's a quadratic? What is it? Because part of the problem of this, so I appreciate that, as simple as that is to do, just going like this. Somebody's holding up 4 fingers, right? 4. Yeah, that's the word quad in there, right? And one of the problems with math is we use language that's very difficult for students, and me too, to assimilate into our brains, right? We're like, what is a quadratic? And if I just knew that, I would have a better understanding of this topic. So here's the generic formula. ax squared plus bx plus c. At some point we'll put equals 0 there when we start solving for roots. At the moment we don't have it. What makes it a quadratic? The power 2. So technically speaking, if you've got anything with a power 2 in it, it becomes a quadratic. So when I was a student, that always bothered me because you held up 4 fingers. Why is it power 2? That always annoyed me. So I came up with this answer. How do we produce a quadratic? And I want to use the example here. Which example do I want to use? Do I need to move this around a little bit? Let's start with one, because I'll use the example to go in the reverse here in a minute. I want to use x plus 3, 2x minus 5. Okay. How many terms inside this? 1, 2. How many terms inside this? 1, 2. Each one of these is a binomial. 2 binomials multiplied by each other. There's a distributive process, or we call it the FOIL method. First, outside, inside, last, F-O-I-L. How many multiplication steps? Now you're back to that. Okay, that's the 4. Everybody go like this, do 4. Okay, that's your quadratic. And how does it produce the power 2? The x times x in this binomial setup, 2x times x becomes 2x squared. Oh, that's the quadratic right there. That's what makes it a quadratic. Outside, -5 times x, -5x. Natalie, get your photo math ready, because I want you to focus, put your window on this, and see if you can get it to do the answer before me or along with me. Inside is 2x times 3 is plus 6x. 3 times a -5 is -15. These are like terms, so we CLT. Everybody say combine like terms. Thank you for that. Okay, 6x minus 5x, because they're like terms, what makes them a like term? There's a power 1 here. And notice we switched from 4 multiplication steps to now an addition. Very confusing for my brain. My brain's doing, okay, I can do all the times. I did all my multiplication steps. But now all of a sudden my brain's being asked to shift to a whole new set of rules. I can't add an x and an x squared, because now you're into addition rules in algebra. And they're different from multiplication rules, right? Multiplication's a little bit simpler. Addition now requires these like terms. But these do have both to the power 1. So 6x minus 5x is 1x. The minus 15, -15 comes down. The 2x squared stays here. And this becomes positive because it's a greater number of positive x's minus 5 of them. So 6 minus 5 leaves you with plus 1x. Did I do it right? And does it work from there? Are you able to go to your photo math app? Try to focus on this one. Let's see if it will. Have you downloaded it? Andrea, do you have room? Do you have space on your phone?
Yeah, but my internet's slow.
You what?
My internet's slow.
Oh, got it. Okay. Okay. So, look what you can go straight to the answer here, right? 2x squared. No, I'm showing it in front of, I don't know if this will refocus. 2x squared plus x minus 15. There's the answer. But the awesome thing about this is they show different orientations. There's the original. Notice how bad my handwriting is. Photomath still picks it up, right? Oh, that's awesome. And it'll show you the tile method, which I don't use very often, but a lot of teachers do. And then it will then start to show you steps. You can expand all the steps. You can further expand each step, and it will explain each step to you, right? I am now obsolete. Obsolete. That word means I'm no longer necessary. You can throw me away and I have to go find some other job, right? Because now you have photo math. And that's really cool. Now more difficult, in fact, let's go to the next step, because remember in math, operations have a forward, where you're walking forward to do operations, and a reverse, where you're walking backwards. And which is easier to me. It's easier to walk forwards when I start walking backwards, right? It's not as easy. So we taught you addition. What's the equal and opposite operation to addition? Then we taught you multiplication, and then we taught you power, and then good, a square root's pretty good. If you just say root, it's generic, because you could cube something and then take the cube root to go backwards, right? So root, there's power and there's root. Then you might say a variation of multiplication and division would be distribution property, the distributive property, and the opposite of that is factoring. This is a form of distribution where we're multiplying across terms and parentheses. Now if you're given this and we have to factor it, that's what we're going to look at. And notice in the factoring from before we did factoring, but notice the addition of this lead coefficient. There's a 2 in here. This makes factoring more difficult. Now, if you went ahead, did you go ahead and use your photo math already? Focus on this one now, and we want it to go back to this, right? And if you have your photo math, I definitely recommend you download it if you have room on your phones. I realize you guys start to tell me you don't have room for additional apps and things. That's fine. Did it do it? Did we go back to here? Okay. So this is a great tool. Let's try to do it manually. Now that we have the computer devices before us, let's also try to do a manual operation. When you're a scientist or an engineer or anything that you're going to be in your future life, you don't just want to rely on the computer or the calculator. You want to go back through this thing and ask yourself, does this make sense to me? Can I somehow replicate the answer manually on my own? There's a couple of methods for factoring. I don't know if these make it any easier. If you look at how complicated this is right here, I'm not sure I like it one bit. Right? I would almost be rather start to go ahead and, wait, where's the one I did? I want to do the same one we just did. 2x minus 5. Does it say x plus 3 right here? I want to factor the same one I just multiplied. There we go. There we go. So let's start with the given problem, which will be this one. 2x squared plus x minus 15. Let's write above it, if you can still see this, ax squared plus bx plus c. And let's define what is a, b, and c. A equals what? What's a? Interesting. But look at the generic, ax squared. Does that help you revise your answer on what a is? What's a? Go, Barry. No? You can always say pass. Pass. Who else? What's a? Anybody else? What do you think? Well, look at, this is the generic. And a generic, maybe there's a better word I can use. Model. Or formula, or the basic setup of how this whole thing works. To be a quadratic, it's got to have that x squared. So notice that the a is in front of the x squared, right? So in this case, does it make sense to you that a is just 2? Does that make sense? Because the model's got the x squared in it. The a is in front of the x squared, so the a is just whatever number is in front of the x squared. What if there was no number here, but there was an x squared? What would a have to be? 1. Don't forget those invisible ones, and we talk about them almost every class. If this is a 5 up here, tell me where an invisible 1 is. Where's an invisible 1? There's 3. The 3 invisible ones. Where are the invisible ones? Where's an invisible 1? Where's an invisible 1 on the 5? Okay, I'm going to tell you. There's 1 times it, because 1 times 5 is 5. There's the power 1, and it's hidden there because everything has to be the power 1. If it wasn't, it would be the power 0, which would make it turn to 1. Okay, and there's a divided by 1 because this is in a numerator position, and that's the denominator position. So the 3 invisible 1s are always hiding there, right? So if this happened to be just an x squared, a would have to be 1 because it's 1 times x squared. Okay, a long explanation, but why am I getting there? Because what is b equal to? 1. Because b is the value in front of the x. You don't see anything, it's hidden, it's invisible, but it's there. It's 1 times the x, so b is 1. And what is c? Louder, I can't hear. I know people are saying something. What's c, Jefferson? What's c? Look at the model. Plus c. Did you say negative 15, which I think you did? Don't forget the negative, because the model says plus. So if it were plus 15, then c would just be 15 because it would fit right into the model. But there, since there's a minus there, c has to have this in it to convert that into the minus there. Fair enough? I've been doing it long enough to know that even though it kind of looks simple to you, where you're like A, B, C, that's got to be boom, boom, boom. I know student brains, this can be very confusing. There's a lot going on. Look at all the complication we get so far. And how much do you appreciate photo math now? Oh, Natalie, look, we're just starting. We're not even down the road. And right? I mean, so let's go down and do this thing. They give us this one in the notes where we do this X model and then this matrix, which has 2 columns and 2 rows. Do you remember that a column is vertical? This would be a column here. A row is across like that. How do you remember? Because if you see a building and it's got a vertical support member, it's called a column. That's the way I always remember it. And then rows are always across. A matrix is just a set of columns and rows. You could have a matrix with, and think of the easiest way, if you're in a Google Doc, right? And you drop in, what's that thing you drop in when you want to put some data in? Not a chart. What's it called? Okay, it's called a table. It's called a table. And it'll say, in Google Docs, you can say, insert a table, and I want it to be 4 by, wait, do they do rows first, or do they do columns first? I kind of forget right now. And I'm forgetting, this is either 3 rows, 1, 2, 3, and 4 columns, 1, 2, 3, 4, and they'll put it into something by this. This would be a row, this would be a column by row. I imagine we could also just tell people it could be a row by column, and I imagine we could switch it, but I kind of forget the protocol on that right at the moment. All right, but we're using a 2 by 2, 2 columns, 2 rows. Here's what we're looking to do inside of this. Now the plot thickens. We want to do A times C. A dot C. We already said A is 2. That came from here. We said C was minus 15. So we want to do 2 times minus 15, which is a negative 30. Then we want to drop in, funny, I forget how this works. There's a 6 and a negative 5. Because we're looking for factors. Good, thank you, I appreciate that. So we have a 6 and a negative 5 in here, right? And what we're looking to do with the factors is multiply them. So 6 times negative 5 produces the negative 30. That's a check on our list. And I believe we're also starting to add them or multiply them. 6. Does this say a 6 here? Or a B, as in boy? I think it might be a B because it's X plus 6x. Man, this is complicated. so 2x from the front minus 5 might be a B,
Yeah.
as in boy. Yeah, and that's why usually I try to use, like right here, go back to my notes. I'll try to use A, B, and C. I hate to start using a B like this and a B like this, even though I try to write them differently. Well, so we start to pull the different factors and pull this together, right? We say 2x here. If the 2x was here and an x was here, 2x times x does produce 2x squared, and I like that. And so you start to play around with the values in the boxes based upon these, and we start to drop in, well, what if the minus 5 was here, and that's coming from this point, and the 6 was here, plus a 6 coming from this point. And I don't like that. Well, let's test it. So negative 5 times x is a negative 5x. Right? I'm not sure about that, but if you're looking here, this is negative 5x. If I'm looking over on this side, 2x times 6 would be 12x. I don't like that at all. What I really need here is a 6x so I can produce the 1x in the middle, right? So I need a 6x here, so I don't like the 6 here. And I'm going to drop in 2x times 3, because 2x times 3 is 6x. And then if I start to multiply negative 5 times 3 and put that here, I do get the negative 15. And now you're starting to see the box produce this value, the 2x squared, right? The 6x minus the 5x and plus an x, and the minus 15 here. If you do a bunch of these, I kind of start to wing it, and I find a lot of this stuff very distracting. I feel like I'm spending more time figuring out the system than the actual problem, right? So what do I like to do? I like to sort of do my wing it method, which over the years I guess I've done a few, and then you start to go, well, let's look at the factors of the lead and the tail. This one's going to have to be something in here. There's going to have to be a 1 times 2. Right? Factors of the tail, since it's negative 15, is going to have to be something like, let's say, negative 3 times 5 would be negative 15. 5 times negative 3 would be negative 15. They may swap. What else could produce a negative 15? 1 times negative 15 could produce a negative 15. Negative 15 times 1. All right. Any other factors that could produce a negative 15? So, and that's a relatively simple one. It could be a lot more difficult depending if we had more factors. But now I'm just looking to build two binomials. I know that one has to be an x and one has to be a 2x. So somewhere in here I've got a 2x and an x. The signs here are going to depend on what produces the outcome. And for me as a student, I would start to guess and check on these, right? I would start to do, let's take this one, minus 3 and a positive 5. And I'd literally refoil it in my mind. Does the 2x times x produce 2x squared? Check, I like that. But if I do the inside and the outside, 5 times 2x is 10x minus 3x. 10x minus 3x is 7x. So I don't like this, it's too high. I need a smaller number. I'm probably gonna go to the next one, and I'm gonna make this, let's reverse these, and make this the plus 5 on this side, and this the minus 3 here. I know my lead term works, 2x squared. Now I'm gonna have a 5x minus the 3x, nope, minus the 6x. So this would be a negative 6x in here, right? So negative 6 plus 5 would be a negative x here. So I don't like that. I'm going to switch the signs now. So I kind of just keep rearranging the terms I've got until it works. Now I've got a 6x minus 5x is going to produce the 1x, and I've got a negative 5 times a positive 3 is a negative 15. I like this method of factoring better. And maybe it's worse if you see it happen, and maybe you're gonna practice it a little bit and see if you can come to that. I think you're gonna use some method of sitting and sifting through problems to see what works for you on factoring. Factoring is definitely more difficult than multiplying, doing the FOIL method, right? FOIL is very formulaic, going backward, a little bit more of play and a little bit more of testing of FOIL going back that way. Right? Okay, I better stop there before announcements start.